Hello, everyone. You are watching the 4.3 lesson video on solving systems of linear equations, I should add, using elimination. So I am secretly hoping that all of y'all remember doing this in 8th grade. I'm pretty sure it was one of your last topics that you did last year when we solved using elimination. And substitution is another method. That's what we're going to do in the next video. So solving systems using elimination is basically what it means. We are going to eliminate one of the variables right off the bat. So if you look at the steps, this is really important info. I'm going to just highlight it up here. We are going to solve each system. Then we're going to write our answer as an ordered pair. For those of you who are like, what's an ordered pair? An ordered pair is just a point. We're just going to write it as a point. And lastly, we are going to check using our calculator. So if you have your calculator, now is a great time to use it. Okay, so without further ado, let's look at number 1. So number 1, we have a system of equations. We can tell that it's a system of equations because we have an x, we have a y, and it's set equal to a number, a constant. We call this the standard form of an equation. So we're used to graphing lines in y equals mx plus b format. That's really the easiest way for us, where we have a starting point and then we know whether or not how we move. These are not as simple. That's why we have this method called elimination that can help us find that point of intersection, that ordered pair, as our answer. So the one thing that I want you to look at and just really embrace it is that we have a negative 6y and a positive 6y. The reason why this brings me so much joy, so much mathematical joy, is when I add the two equations together, I end up getting 5x plus 3x, which is 8x. Negative 6 plus 6 is 0. They're gone. So that term is eliminated, hence the term elimination. And then negative 32 plus 48, what is that? 16. Okay, so what are we going to do next? Well, this is simple. We have 8x is equal to 16. Divide both sides by 8. I'm glad that you guys were thinking that before I even wrote it, because it's always great to be ahead of your teacher. And I know that all of you know that 16 divided by 8 is dos. That's 2 in Espanol. Many people think we're done. We are not done, because we just have the x value. And of course, we're looking at two lines in the coordinate plane and they're crisscrossing. The coordinate of that, so part of my answer is x equals 2, but I still need my y. So you can play eeny, meeny, miny, mo. I don't care what equation that you use. I personally like to keep it simple. I like to take the easy way out. I hope that you do too. So I'm going to pick the equation that doesn't have as many negatives. So I'm going to write the 3x plus 6y down, equals 48. Whoa, what just happened? Okay, equals 48 on my paper. Now check it out. X is 2. So even though the method is called elimination, we are going to do a little bit of substitution here. Anytime we see an x value, we are going to sub in 2. So everything else looks the same. I'll still have my 3 times 2 plus 6y equals 48. Now we're able to figure out what y is because we only have one variable. So let's just keep on going with it. 3 times 2 is 6 plus 6y. Some of you are like, I get what you're doing, Mrs. Ruscio. Okay, cool. So what we'll do next, let's move the 6 over. Some of you might like to use sorting. That's cool too. But here I get 6y is equal to 42. Divide both sides. I mean, we're just going back to basic equations here. So this is everything that we did in Unit 1 and really math, I think, up till this point, especially in the middle school. So it's okay to leave your answer like this, but they told us in the directions to write it as an ordered pair. So if you can just close your eyes and visualize two lines crisscrossing at the point 2, 7, you are thinking of this system right here. Okay, moving on to number 2. How much time did I talk too much, don't I? How much time has this been? Okay, so let's look at number 2. I'm talking too much, apparently, because we're almost halfway through this video. And I have like 3 more questions to go, so we're going to talk real fast. Just kidding. I'll just go through it. And if you need to pause the video, you can. 3x plus 2y equals 10, and 3x plus 2y equals 8. So hold the phone here. I loved number 1 because I had the additive inverse happening. That's why I highlighted it in blue. That is almost happening in number 2. Like, look at it, look at it. It's almost there. Actually, it's in my x values as well. This is magical. Okay, but there's a problem because if I added those together, 3 plus 3 is 6, not 0. So what we're going to do is we are going to just bring in a handy dandy multiplier. And guess what we're going to multiply it by? If you thought -1, you are right. Dun, 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 dun. So I'm just going to copy paste my first equation down, 3x plus 2y equals 10. And then if I multiply every term by -1, I get -3x minus 2y equals not +8, but -8. Now, when I add these guys together, something really cool happens. 3x minus 3x is 0. And oh my gosh, this is wild. 2y minus 2y is also 0? So what the heck? I have 0 equaling 10 minus 8, which is 2. What? Does 0 ever equal -2? No, never. So you want to know what this means? There is something that we call no solution. When would you have 2 lines graphed that have no solution? If you thought the word parallel, you are right. They're parallel lines. They don't have a solution. They'll never cross. They're never going to intersect at a point. Okay, now moving on to number 3. You can see example number 4 is done for you. We might talk about it if we have time. Now, if I look at number 3, it's not as easy as it seemed in 1 and 2. Like, I don't have those special numbers being the same number, maybe the same number, opposite signs, or just the same number. I have to force this to happen. So I can either multiply my top by something, I can multiply the bottom equation by something, I can multiply both of them to force it to happen, that beautiful additive inverse. So if you look at this, I want you to just creep on this plus y for a minute. Like, that's a 1, right? I'm just going to write that in there for those of us who weren't sure. I want that 1 to become a -4. So the only way that I can make that happen is if I multiply this entire equation here by -1. Okay. No, not by -1. Yeah, you're right. You're like, Mrs. Ruscio, you're crazy. Stop rushing. Stop trying to finish the video so quick. We have to multiply it by, how do I get it? -4. My computer does not like me today. So -4 right here. Okay, let's rock and roll. Let's see why this is so magical now. So 2x plus 4y equals 8. And then if I multiply the -4, I end up with -20x minus 4y equals positive 28. Do you see the magic now? Like, look at the magic. What is going to happen when I add these together? 4y minus 4y is 0. What's 2x minus 20x? Yeah, you were right. That's -18x. And the same thing with 8 plus 28. That ends up giving us 36. And look at, we're right back to where we began, okay? So what are we going to do? We're going to divide both sides by -18. We're like back in the basic land of solving equations. Okay, so what do we get? -2. X equals -2. Okay, I'm going to pause the video and I want you to finish off the rest of this question. Okay, so here's my work for finishing up the solve. So I needed to figure out my y value because I found my x value to be -2, and I ended up substituting it back in. Like I told you, I picked the easier of the two. I mean, I guess you could have picked the bottom one because you'd still get the same answer. And I ended up with y equaling 3. So the point of intersection is at -2, 3. So we have a couple ways to check at this point. We're going to do the check just on this question. I know it said to do it on all of them. Let's just do it right over here. So what I'm going to do is head over to the calculator, and I need my example. So we have 2x plus 4y equals 8. And let's open up a calculate page. We're going to go to Menu, Algebra, Solve systems of linear equations. We have 2 of them, and our variables are x, y. So we're just going to hit OK. And then my equation that I have was 2x plus 4y equals 8. And we're going to go right back to the original. So 2x plus 4y equals 8. And then in the bottom, we are going to type in the other one, which was 5x plus y equals negative 7. The original one, 5x plus y equals 7. Then hit enter. Oops, that was supposed to be negative 7. Have you guys seen the copy paste tool? Look at that, I messed it up. And some of you are probably like, don't push enter, you did something wrong, I'm sorry. All right, let's put in the negative 7. The reason why I knew I did something wrong was because it didn't give me the answer that I got. So I'm gonna look back and realize, oh, duh, you forgot to put the negative 7. So it's negative 2, 3. Let's see, is that what we got? Oh my gosh. Oh, what's happening? My screen won't let me. Oh, this is so tragic. Okay, negative 2, 3, negative 2, 3. So some of you are like, whoa, that's mind-blowing. Can I just do this and not show any algebra? The answer is no. You do this on a Regents exam, you get a big fat 0. But this is a wonderful way to check. Some of you might say, hey, I would rather just graph the two and find the point of intersection. Is that cool too? Of course it is. So whatever method that you think that you need to do to solve and check your work, I want you to do it. Just remember that if you're going to be graphing these, you want to graph them in relation mode because they're in standard form. Now, the last work through example, I want to address the fact that for some reason I just got really excited and I eliminated all my x's. Actually, I'm just kidding. I eliminated my y's. So I always solve for x first. You don't have to do that. So if you are like, it's so much easier for me to get rid of the x's, then get rid of the x's and solve for y first. It works the same exact way. Number 4 was a little sneaky because I wasn't able to just multiply one equation. So instead, I looked at my additive inverses, kind of. I saw that there was a negative here and a positive there. So I decided to multiply my entire top equation by 3 and my entire bottom equation by 2. The reason why this worked out so nicely is because when I did that, I ended up getting negative 6y and a positive 6y. Another suggestion or another idea that you could have done is you could also have multiplied the top equation by 2 and the bottom equation by negative 5. If I did that, I would now try to eliminate my x values. So if I just do that quickly, just so that you guys can see how it would look eliminating x's, I would get 10x minus 4y is equal to 40. And in my bottom equation, oh, I can't do that math in my head with a 27 times negative 5, but you get the picture. So we'll get negative 10x minus 15y equals whatever value that is. Because when we add them together, do you see it? Do you see it? Do you see it? Then we would get rid of the x's. So there's always multiple ways to solve these systems. This is just a really nice worked through example for those of you who didn't watch the video. You're not even listening right now because you didn't watch the video, but you can look back in your notes and reference this at any point because it's in beautiful, beautiful colors.